Alright, here goes the review. In number 1, when we need to add, we just need to combine like terms. So we're going to add the coefficients and leave the exponents. So we'll add 7e to the third plus 1e to the third, and that'll be 8e to the third. We will take the e to the seconds. We have negative 1 here, and we'll add on 5 right there. So that'll be plus 4e to the seconds. And then finally, we have that minus 3 and no other numbers. So that's the final answer. On number 2, we're going to multiply this by this term and that term. So here goes the first one. Negative 5 times negative 5 is 25. And when we multiply, we add up the exponents. So it's going to be c to the 6th, because 2 plus 4 is 6. And then we'll add up the exponents on the d's. 5 and 3 is 8. Next, we'll do negative 5 times 4, so that's negative 20. We have c to the second and no more c's, so it stays c to the second, and then d to the 5th and d to the 1st is d to the 2nd. So there's that final answer. Number 3, let's start by looking for a GCF. We can divide each of these terms by negative 5, because the leading coefficient is negative, and x to the third. So that's the GCF. Divide everything by negative 5, x to the third. So we'll write the GCF out front, and we'll write the leftovers right next to it. Those 5's cancel out, and you're left with x squared. Negative 15 divided by negative 5 right there is positive 3x. And then last, the 20 divided by negative 5, that's minus 4. So we have to solve this all the way, which means we're looking for what the x is equal. We know we're going to have a couple different answers because this is degree 5. We don't have to list the multiplicity, so I don't need to worry about that for this, but we are going to keep factoring the leftovers right here. Since it's a trinomial, I'm going to rewrite the negative 5x to the third out front. It's a 3. And try to break the trinomial into 2 factors. X and x is x squared. And we're going to look for the factors of negative 4, the factors of 4 that subtract to give you positive 3. And if you do positive 4 minus 1, that'll give you positive 3. So the last step is to set each of these equal to 0. In other words, you're trying to figure out what does x need to be so that all of that equals 0. Well, x needs to be 0, so there's one answer. Here, x would need to be negative 4, and here x needs to equal 1. So those 3 are your answers. Don't worry about listing the multiplicity because it doesn't ask for that in this problem. Number 4, I'm going to do synthetic division, I guess in this space right here. First, I'll put positive 3 in the box. Next, I need to make sure that these are in standard form with no skips. I start with x to the third, so I know the 2 goes first. There aren't any x squareds, so I'll put a 0. Then the 8, x to the firsts, and then the minus 4. So we'll put the line underneath and start synthetic. Drop the 2. 3 times 2 is 6. 0 plus 6 is 6. 3 times 6 is 18. And 18 plus 8 is 26. 3 times 26 is 78. And negative 4 plus 78 is 74. So we'll rewrite the final answer, but this time instead of starting with the highest exponent x to the third, next to the 2, it'll be only x squared. So it'll be 2x squared, and then the positive 6 with an x next to it, and then the plus 26, and then since the 74 is positive, we'll put plus 74 over the x minus 3. So that red part is the answer to number 4. Let's do number 5 in a different color. We'll do that one in green. So we have x minus 4, which means I'll put positive 4 in the box. These are in standard form to the second, to the first, nothing, with no skips. So we'll take 6, -8, and 3. So we'll put the line, drop the 6. 4 times 6 is 24, and -8 plus 24 is 16. 4 times 16 is 64, and 3 plus 64 is 67. So the final answer, I'll write in green. Instead of starting with x to the second, the first variable next to that 6 will be just plain x, then the plus 16, and then the plus 67 over the x minus 4. Done. In order to do number 6, all we're doing is evaluating. So basically we could just plug 3 in for all of those x's and calculate it out right in the calculator and get the final answer. Or since x equals 3, we can just go ahead and put that in the box and do synthetic with this. So don't forget your leading coefficient is 1. We have to the third, to the second, to the first, and exponent 0, so we're good. So our coefficients will be 1, -3, 4, and -5. When we do this, the remainder will be our final answer. So we'll drop the 1. 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. 4 plus 0 is 4. 3 times 4 is 12. And -5 plus 12 is 7. So since 7 is the remainder, 7 is the final answer. Number 7, you need to type the equation into y equals on the calculator. And when we describe it, we describe that the graph alternately, first it increases and then it decreases. The shape is sort of like that. So we say increases and decreases. It changes directions 3 times. That's when we're looking for the hills and valleys right there, there, and there. It crosses the x-axis 2 times, and it's sort of like, I can't draw it right now, so there appears to be 2 real zeros. I don't have enough room, but if you were looking at that on your calculator, it would cross the x-axis twice. So that's where we get that answer. On number 8, we need to identify 2 things, the leading coefficient and the degree. The leading coefficient will either be positive or negative. The degree will either be even or odd. So we look at the graph, and I notice that the arrows are pointing down. So that means the leading coefficient is negative, because negative means it opens down. Since they both point the same direction, it means that the degree is even. So negative and even. On number 9, we're going to divide all 3 terms on top by x to the third. So I'm going to write an x to the third underneath each of them and then simplify, which means we're just going to be subtracting the exponents on the same letters. So the answer will be 7, and then when we divide those, 7 minus 3 is x to the 4th, and there aren't any y's on the bottom, so it stays y to the 5th. Next, when we look in the middle, we'll have plus 6. When we cancel out those, it's going to bring it down to x to the third, and those y's stay. And then last, nothing's being divided by the -2, and when we divide those x's, 5 minus 3 is x to the second with the y next to it. That blue is the final answer. Alright, number 10. Since we have no GCF, we're going to break it into 2 factors because we have 2 perfect squares and a minus sign. So x squared times x squared is x to the 4th, and the square root of 625 is 25. So we'll have one with a plus 25 and one with a minus 25. And we keep going. We can't factor perfect squares with a plus sign, so we're going to set that equal to 0 and go through the process of solving it for x squared. So we'll subtract 25 from both sides. And when we do that, we get x squared equals -25. And then the next step would be to square root both sides, but we can't square root a negative, So our answer is plus or minus 5i. The answers are imaginary. So there's 2 of the answers. Now we just need to get the other 2 by factoring that. So I'll factor that part in green. We do have 2 perfect squares. They do have a minus sign. So x times x is x squared. And the square root of 25 is 5. 1 with a plus, 1 with a minus. The next step is to write each of those. Your final answer will be -5 and +5.